We're gonna see the code now, and first we're gonna start with the function ID. There's the main with different pointers to different parts of the superblock. Then we have to get into the file. Then we have the main copy, so we can enter it can take from the binary file into the different type of structs, and then we can go to see the command. It's an fget simple. Then we have some else if and the error zone, so we can show if the command is wrong. Then we can see different else ifs, and now we are gonna go to the functions themselves that I made. First, we're gonna go to print bitemaps. That's the one that shows the arrays of inodes and blocks. It's a simple array here, and it goes to see if they are occupied or not, and it gives you a value, and it's really easy. It's a very simple function. Then we have le superbloque here, that it just accesses the superblock and shows the different parts of the superblock and the different data. Then we have print. There's a different difficult one. First, we go to see if there's if the file exists, and it gets the directory index, and if not, there's an error for that. And then it's in a simple algorithm that creates another pointer to another structure, so we don't use this one, and gets from inodes and the directory we found with its direction, and then we create an int block index. It goes through all the blocks in the inode to see which one is not null, so we can see which ones are corresponding to the data, and it goes here and block 0, the first pointer of the array, goes to inode of I, so we can see which one are occupied, and then it mems copy to print text, the data of the mem datos that contains the text itself here, and prints it, and it repeats until the blocks are over, and then it frees the print text. Then we go to directory. Directory gets the directory pointer and the inodes directory pointer, and then we go through the inodes to see which ones are not null, so we can see which files do have an inode assigned to them that is occupied, and then we get to this point in the directory, and we put the name, the size of the and the inode we just saw. Then to print the blocks, we just get here and go through the inode we found and start printing the blocks, and with a for loop. Really easy.
The exit function is very straightforward. Once it detects the command, it saves the data and exits the program. The rename command functions by searching for the file that you want to rename and then seeing if the new name is already in use. It does this by looping through the non-empty inodes and comparing the names to see if they exist or not. When the file to be renamed is found, its name is changed from the directory pointer, assuming that that new name is not in use already. To delete a file, we first need to find it using the same method used before. Once we have found the file, we need to mark all the resources that it is used, inodes and block, as free. To copy a file, we first need to search for the source file and see if the name for the new file is already in use. Once we know that we can start making the copy, the first thing we do is surf the directory pointer and the inode bitmap to find a free directory entry and an inode that we can use. Should there be none left, the user will be informed and the function will be stopped. Next thing we do is copy the metadata from the source file to the destination file, with a couple of tweaks. The destination file name is changed, and also the blocks stored in the destination inode are made null, so they're not pointing to any real blocks yet. Now, we need to find free blocks that the destination file can use to fill it with information from the source file. We do this by searching the blocks bytemap to see if there are any blocks free. When we find one, we mark it as used and we put the data from the source file, from the corresponding block, in this new block we just found. If no blocks are found, we need to make sure that any blocks that have already been used by the destination file go back to being unused, and that any reference by the inode block array go back to being null references. Once we have finished copying the file, we mark the inode as used and inform the user that the copy has been completed successfully.
Today we're gonna see the programs we made for operating systems for the Unit 5 file systems. And first we're gonna see our files we have here. For example, dir. We can put the command dir to see the different files we have. We're gonna print the contents of hola.txt, hola que hace, and print the contents of bellogal.txt. Then we're gonna see several other commands like rename. Like we can rename a file. For example, we can rename hola.txt as.txt, and we can say dir to see that we have now hola is called as.txt with the same inode, the same blocks, and the same everything. And if we print as.txt, we can see that it's the same file. Then we can remove a file, remove chiste.txt, and we can go to dir again to see that it's removed. And then we have several other commands like info to see the information of our superblock. Then we have bitemaps to see the different blocks that are being occupied in the first 25 blocks and the inodes that are occupied in the partition. We can copy a file, for example, one we rename, that is as.txt, and you can see the error message because we didn't put a second file, we didn't rename the second one, so we can copy as.txt as2.txt, and the file is copied. We can go to dir, and we have bellogal as and as2.txt, and we can also do salir to exit salir. But then first we can put some random layers to see the different things we have here, the different commands and what they do. So it's an error message, and we can go to salir and exit.